Again, you're welcome to Waidsum Academy. Today we're looking at Maths chapter 18, graphs of functions. Remember we've done graph and conversion graphs and travel graph in chapter 17. Today we're looking at proper graphs like plotting linear graph, plotting quadratic graph, reciprocal graphs, cubic graph, all the plotting of graph that you know in mathematics. This chapter 18. So without much ado, let's begin quickly. Now here we'll be looking at quadratic function first. You know, quadratic functions are of the form as squared, ax squared plus bx, ax squared plus bx plus c, right? Plus c. This is a quadratic expression. Okay. When it becomes equal to something, it becomes quadratic equation. Okay, this is a quadratic. Why is it quadratic? Because the highest power of x is 2. The highest power of x is 2. So any quadratic function is given in this format. Any quadratic function is given in this format. Will be in this format. This is a quadratic function. Okay? So, or explain like this: ax squared plus bx plus c. So this is a quadratic function where a is the coefficient of x squared and b is the coefficient of x and c is a constant. C is what? A constant. Okay, so any equation that is of this similitude or that looks like this is a quadratic equation. Especially if it's expressed as y equal to that equation. So if we say y equal to 2x squared plus 3x plus 12, this is a quadratic equation. And when we can plot this graph, and the graph of this is going to give us something like this. It's going to give us something like this, a U-shaped graph like this. And if it's a negative one, it's going to give us a graph like this. So these are the two forms of quadratic graphs. This is how the quadratic graph looks like. So when we go to plot, we're going to choose a range of values of x, and we make a table. We substitute the values of x. The values we've chosen, we substitute for x, and then we get the corresponding values of y, and then we plot the values of x and the values of y. X on the horizontal axis and y on the vertical axis, and then we plot our graph and we draw our graph and we see how it looks like. So all these examples are examples of quadratic functions. All these ones are examples of quadratic function. Like this one is also an example of quadratic function. Y equal to x squared minus 5x plus 6, and y equals to 3x squared plus 2x minus 3. These are all quadratic functions because the highest power of x is 2. Why is it quadratic? Because the highest power of x is 2. If the highest power of x is 3, we call it a cubic function. So a graph of quadratic function produces a smooth curve that we call parabola. So parabola, like this one I've just shown you, this is a parabola. Okay, this is a parabola. And this one is a parabola. We produce a smooth curve that we call parabola. Okay, so it produces any graph of quadratic function produces a smooth curve called parabola. And we can start from a simple quadratic function of y equal to x squared. Okay, a simple basic one of y equal to x squared. We can have the table we do for y equal to x squared and y equal to negative we do for y equal to x squared and y equal to negative x squared. Okay, we can do for both of these, y equal to x squared and y equal to negative x squared. And we get their table and we plot their graph. The positive one will look like this graph, it looks like this one, and the negative one, y equal to negative x squared, will look like this other one. Now let's look into our table. Let's plot our table. We choose the range of values of x by ourselves. Okay, most of the time, except you're told to choose x lesser than or equal to 4, greater than or equal to negative 4. If you give it to choose, if you are chosen for, then you use what is given to you. But other than that, you do 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4. Now, then you put negative 4 in place of here. Okay, because that's the value of x now. Negative 4 squared, you have to put bracket. If you don't put bracket, you get negative 16, and which will be not correct. So you put bracket, you say minus, open bracket, you say minus. You open bracket, you say minus 4 square, and you get positive 16. You open another bracket, you say minus 3 square, you get positive 9. Minus 2 square, you get, well, you can do it from your calculator now, you can check. Okay, but put this one in a bracket and then you square it, you get positive. So you get corresponding values of y. Then we do for negative. This one will be minus 4 square. You remember this, there's a minus here and there is a minus 4 for x. So that minus 4 is we square, you get positive 16. Positive 16, it now become minus, and positive 16 will become minus 16, will become negative 16. Same goes with this one. Negative 3 square, you get positive 9. But because of the minus here, this one will become minus 9. And then this one, you get the same thing. Then we plot. After we get this table of value for both s squared and minus s squared, then we plot the two graphs. This is the first parabola. This one is our first parabola. Okay, for the positive one. This is the positive parabola. Okay, now you notice how the quadratic function has a line of symmetry through its turning point. Here's the turning point, this place. You know, this is the graph. It comes down here, and then when it comes down to this place, it has to turn and start to go up, right? So this place is called the turning point. This place is called the turning point. So that turning point, you can draw a line of symmetry, meaning a line of symmetry is a line that can divide this quadratic graph into two equal parts. Okay, so at this turning point, it has a line of symmetry. Now, how do we get this? We plot the table value, the values of this table for y equal to s squared. Minus 4, look at it, minus 4 here. You have to trace it to what? Positive 16. You have to do your scale in a graph. You do negative because your x values are from minus 4 to positive 4. You do it here on the horizontal side. And then you do, since you see your table, the highest value is 16, you can do from, there's no negative value on your table. Since there's no negative value on our table for y-axis, there's no negative value. And y-axis is the vertical axis. Then we do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. And then we can stop because the highest one is actually 16. And then we start to trace. We trace negative 4 on the x-axis to positive 16 on the y-axis. That's here. Trace this one. Trace this one. Negative 4 on the x-axis to positive 16 on the y-axis, and put a point there. And put a point there, okay? And put a point there, right? Trace this one. Then the next one is negative 3. Trace it to 9. Negative 3 on the x-axis. Trace it to 9 on the y-axis. Here is 9. Here. Because if you bring it here, you get 9 here. If you bring it here, 9 is somewhere here, halfway between 10 and 8. So you put the point there. You put your second point there, right? Put your second point there. Then you come to this one, negative 2, you trace it to 4. Negative 2 on the x-axis. Here is negative 2 on the x-axis. Trace it to 4 on the y-axis. So we trace this one, negative 2 on the x-axis to 4 on the y-axis, right? To 4 on the y-axis, you see? This is 4 on the y-axis. So we put a point there. Put a point there. Then you trace the next one, negative 1 to 1. Negative 1 on the x-axis to 1 on the y-axis. So it means just here to here, to this place. Remember, 1 is halfway between 0 and 1 and 2. So 1 is here. So you put a point there. Okay, this is how you plot a graph. I'm just showing you how you plot a graph. Trace 0 to 0. So 0 to 0 means here. 0 on the x-axis and 0 on the y-axis, they are both here, same spot. And then trace 1 to 1. 1 on the x-axis, trace it to 1 on the y-axis. That's here. Okay, you put the point there. Then trace 2 on the x-axis to 4 on the y-axis. Trace 2 on the x-axis, trace it to 4 on the y-axis. Here is 4 on the y-axis. Where they meet, it's a coordinate point. Where they meet, you put a point there. Then trace 3, the next one is 3, right? Trace 3 to 9. Come here, trace 3. 3 on the x-axis, trace it to 9 on the y-axis. Trace it to 9 on the y-axis. You get this. You put a point there where 9 is, okay? Because if you bring this here, 9 is somewhere here. You trace it and you put the point here. Put the coordinate point here. And then the last one, 4 to 16. Trace 4 on the x-axis to 16 on the y-axis. Trace it to 16 on the y-axis. You get this point here. Here is where 16 is. Then what do? You take, you can use a broomstick, or if your hand is very good at joining points. Okay, this is a curve. It's not a straight line, okay? You're not going to use a ruler to draw a curve. So you begin to join the points as a curve. gradually, you draw, you join the points, you join the points, you join the points, you join the point, then you get the graph. Any question can be asked thereafter. Okay? Any question can be asked thereafter. Okay, that's for the positive one. The same applies to the negative one. We don't need, I'll just show you like 1 or 2 examples. -4 to -16. Trace -4. This one you can see on the y-axis all the values are negative except 0. So meaning we should create the values down for the y-axis. Create the negative side on the y-axis, create it downwards. Okay, so then you put the x-axis upward. Okay, now -4 to -16. Trace -4 to -16. You get the point here. Trace -3 to -9. Put the point here. Trace -2 to -4. Put the point here. Trace -1 to -1. Put the point here. Trace 0 to 0. That's exactly this spot, the turning point. Then trace 1 to 1. This place. 1 to -1. Sorry. This place. Trace 2 to -4. This place. Trace 3 to -9. This place. And trace 4 to -60. This place. Then you join also. Then you draw the graph. You join them together. You join all the points together with a curve. So I hope you get the message. So others will be faster because we've showed you how to plot a graph. Okay, now let's take a look at this one. I say plot a graph of the function y equals to x squared minus 5x plus 6, and they give you range of values. They give you the domain of values of x. They give you the domain. Okay, the range is for y-axis. The domain is for x-axis. Okay, they give you the domain of the value of x, meaning they tell you that you should choose values for x from 0 to 5. X is lesser than or equal to 5, greater than or equal to 0, meaning you should start from 0 and end with 5 in your table of x. 0, 1, 2, 3, 4, 5. Then you substitute them into this equation. The first one is 0. Substitute 0 into this equation. 0 squared, you get 0, minus 5 times 0, you get 0, plus 6. So your y value will be 6. Then you substitute the next value, 1. Substitute 1 here. 1 squared is 1. 1 times -5, you get -5. Okay, plus 6. So you have 1 minus 5, that's -4, plus 6, you get 2. So that's how we got 2 here. That's how we got 2 here. Okay, then the next is to substitute these 2 into this equation. Anywhere you see x, you put 2. So 2 squared, you get 4, minus 5 times 2, that's 10. So 4 minus 10, you get -6. -6 plus 6, you get 0. That's how we got 0 here. That's how we got 0 for the value of y. Then the next thing is substitute 3 also into the equation. Anywhere you see x, you put 3. 3 squared, you get 9, minus 15, because this is 3 times 5, -15. So 9 minus 15, we get -6, right? -6 plus 6, we get 0 as well. That's how they got this 0. The next one is to substitute 4 into this equation. 4 squared, you get 16. 4 times this, you get -20. So 16 minus -20, you get -4, right? -4 plus 2, you get 2. You get 2. That's how we got these 2. And then substitute 5 here. 5 squared, you get 25. 5 times 5, you get 25. So it becomes 25 minus 25. You're going to get 0 plus 6, you get 6. That's how we got 6 here. So once you get your table of values, this is the first thing you do when you plot a graph. You quickly have to get your table of values for x and y. Once you choose your values of x. If they don't give you the domain to choose, you choose yourself from 0 to 4, 0 to 5, or from -3 to +3. You choose values of x, and then you get the corresponding value of y, and then you plot your graph. Now, how you plot your graph? Trace 0 to 6, 0 on the x-axis. You come here, this 0 on the x-axis. Trace it to 6 on y-axis. Trace it to what? 6 on y-axis. Trace it to this place. We are here. Trace 1 to 2. Then y on x-axis, trace it to 2 on y-axis. You come here, you put the point here. Trace 2 to 0, you get here. 2 to 0, you get here. Trace 3 to 0, you are also here. Trace 4 to 2, you're here. Trace 4 to 2, you're here. And trace 5 to 6, you are here. Okay, now you join together. Remember, this one is at the same point. So you don't make it flat. You don't make a flat curve. You still have to make it curvy a little bit downward. A little bit downward. So you join the points. You join the points. You join the points. And you get the graph. Okay, you get the graph. So this is how we plot the graph. For negative 1, if you have once you have minus here, you know the graph is going to be like n. Once you have plus positive coefficient of x, if here is positive, your graph is going to be like u. It's going to be like u. For positive graph, it's going to be like u. For negative coefficient of x squared, your graph is going to be like n. So if we do the same thing, we get this graph. Is that okay? We get this graph because we already explained that. So here, you pause the video. Please solve these questions. They give you the domain of values of x that you should use for each of these, and then you get the corresponding values of y, and then you plot the graph for each of these. At least even if you don't want to plot all, at least select some here and plot. Okay, select some and plot. Now let's go to the graphical solution of quadratic equation. Now this is when you have a graph and then they give you questions to solve. First we plot the graph. You say draw a graph of y equals to x squared minus 4x plus 3 for s is lesser than or equal to 5 and greater than or equal to negative 2. Okay, so they give you the domains of values of x. So you draw a table, you put all your values of x, minus 2, minus 1, 0, 1, 2, 3, 4, 5. And then you can get the corresponding values of y by substituting the values of x. Every spot value of x, you substitute it where? You substitute it into this equation. Meaning here will be minus 2 squared, you get 4. Okay, negative 4 times negative 2, you get positive 8. So 4 plus 8, you get 12. 12 plus 3, you get 15. Okay, see, you get 15. Okay, so you substitute 1 here, you get 8. If you substitute 1 into this equation, you get 8. If you substitute 0 here, you get 3. Why? Here will be 0. 0 squared is 0. 4 minus 4 times 0 is 0. So only 3 left. That's how we got 3 here. Substitute 1, you get 0. Substitute 2, you get. So once you get your table of value ready, okay, then you plot the graph. Now the first thing to do is trace negative 2 on the x-axis. You choose your scale on the graph. Once you choose your scale, you go to negative 2 on the x-axis, trace it to 50 on the y-axis. Trace negative 2 to 50. Trace it. Trace negative 2, okay, on the x-axis to 50 on the y-axis. To 50 on the y-axis. See, 50 is halfway between 60 and 40. You put the point there. Okay? Then the next thing, negative 1, trace it to 8. Trace negative 1, this one, from here. Trace negative 1 to 8. Trace it to 8. It's a coordinate point. You get the point. The coordinate 8 is here. So you put the point where they meet. Where this negative 1 and 8 on the y-axis where they meet, you put the point there. Trace 0 to 3. 0. This 0 on the x-axis, this point, this place. Trace it to 3. 3 is between 2 and 4. You put it here, halfway between 2 and 4. Trace 1 to 0. Okay, 1 to 0 means 1 on x-axis, 0 on y-axis. It will just be on this horizontal line, the 0 line. It will just be on this 0 line. Put the point there. Okay. Then this one means trace 2 to negative 1. 2 on x-axis, this 2, trace it to negative 1, meaning you go down. Negative 1 is here. It's halfway between 0 and 2. Put it here. Put a point there. Okay. Now trace 3 to 0. 3 on x-axis to 0 on y-axis. 0. This is 0 on y-axis. This place. So meaning on that same horizontal line, the horizontal x-axis line. Put a point there. Trace 4 to 3. Trace 4 to 3. 3 is between 2 and 4. Halfway between 2 and 4. So you put the point there. Trace 5 to 8. Trace 5 to 8. See? Okay, for this graph, you join the points as a curve. Just the point, then here is curving down. Okay, you don't draw because the points are here and here. You don't just, this one, okay, there's a point here actually. Then you join this point, and then you get your quadratic graph. You get carefully with pencil. Okay, you don't plot graph with pen, okay? With pencil, in case you make mistake, you erase and do it again nicely. Is that okay? Now, questions will be asked. Questions will be asked. Use the graph to solve the equation. See, use the graph to solve the equation. After you plot the graph, you want to solve the equation s squared minus 4s plus 3 equal to 0. Now, check the original equation. Is this the same? S squared minus 4s plus 3. Yes. It's s squared minus 4s plus 3. You know it was equal to y. What this means is that, you know, original equation here was y. Y equal to the whole of this. Now they are telling you is 0, meaning y is 0. Where is y 0 in the graph? Y is 0 here, this place. Y is 0 here. Let's take a highlighter. Y is 0 here. this place. Y0 here. This is the 0 point. So if they use it to solve the equation, where does the 0 on y-axis, where does it touch the curve? At s equal to 1 and what? At s equal to 3. So this will become the root of the quadratic solution. This will be s equal to 1, s equal to 2, 3. So when you plot graph, you can use graphical method to solve quadratic equation. You plot it and then you find the root. Okay? So if y equal to 0, meaning x will be what? This point, 1 and 3. That's where, if you trace the 0 on y-axis to where it touched the graph, you know quadratic, you touch the graph in two places, here at this point and at this point. So your solution will be s equal to 1 and s equal to 3. S equal to 1 and s equal to 3. But if they say 2, for example, they say solve it, and they say s squared minus 4s plus 3 equal to 2. Let's say equal to 2, not equal to 0. What would that be the solution? If they said, oh, solve the equation s squared minus 4x plus 3 equal to 2, not equal to 0. You know what you do? You come to the graph. Where is 2? Here, draw a line on y equal to 2. Because this value is the value of y. Okay, y equal to 2 will be what? So no matter value they put here, no matter the value they put here, if they say 5, you come where 5 is, you draw a line there. So where the line touch the curve at this point and at this point, you trace them down to the x-axis. You get the solution, the root of the equation. Okay, if they say it's equal to 2, this equation is equal to 2, or y equal to 2, we should find the solution. You trace here, it touch here, it touch this curve at what? At where? This point, right? At this point, which is like 0 point something, and the second spot where it touch is here, which is like 3 point something, not up to 4, and greater than 0. Let's say 0.2 and 3.8, something like that. Those will be the roots of the solution of the quadratic graph. So no matter what they say this one equal to, you just go, because what they say is equal to is the value of y. Remember they define y to be equal to this quadratic. So if they say it's equal to 0, meaning y is 0. They say equal to 2, y is 2. So you just go to y-axis and draw a line across that number they say is equal to, where the line touch the curve. You know it will touch the curve mostly in two places, except you're above this point. If you're above here, it will touch the curve in one place, maybe at 12. They say well, this is equal to 12, then it will touch the curve only in one place. It will not touch the curve in two places. But anything here to touch the curve in two places, where it touch the curve, trace it down to the x-axis. Trace the both side down to the x-axis, the value becomes the root of the equation. Okay, so here you pause the video and solve all these questions here, all this exercise, 80.2. Now let's move on to this next one. He said we should use the graph of y equal to s squared minus 4x plus 3, the same graph we plotted just now, to solve the equation s squared minus 4x plus 1 equal to 0. Now you can see a difference between the original one and what they asked you to solve now. There's a difference. Here was plus 3, here was plus 3, and here is what? Plus 1. So there's a difference of 2. There's a difference of 2. So if I want them to be the same, I have to make them to be equivalent to this one. How can I make this equation? How can we make this equation to be equivalent to this one? By what? By adding 2. You know, here was 3. The only difference was here was 3, here was 1. Here is 1, and here was what? 3. So what will we do? What if we say this one, we use the original one, we say is equal to 2. If we say s squared minus 3x plus 3 equal to 2. If we say that, will it be same as this one? Logically, yes. Why? Because if you move this 2 to the left, it will be 3 minus 2. That's 1, which is this one. So please pay attention. When they give us the original equation, this is the original equation. Now, they're asking us to use this original equation to solve a new equation. There's always a similitude. One thing you can do is to subtract both equations and find the difference. That difference, you can equate it to that difference. So you write the original one, you say it's equal to whatever that difference. If I say S squared minus S squared, I get 0, right? Minus 4S minus 4S will be equal to 0. 3 minus 1, it will be equal to 2. 2 is the difference between this one and this one. So that difference, you write this one, this original equation, you say equal to 2. You write the original, you say you say S squared, sorry, not Y, S squared S squared minus S squared minus 4x minus 4x plus 3 equal to 2. Equal to 2. Why? Why did we say equal to 2? Because if you now make this original one to be equal to 2, it will be exactly this one they ask you to solve. They are not equal. They are not same. Why? Because this to bring it to the left, it will be 3 minus 2, which is 1, which now makes this to be exact as this. So what it means is that go to your original graph. Why did we do that? Because we cannot change the graph. We are using the same graph. So this original graph has to remain. This equation has to remain. You only find a logic, what you do to it, to make it same as this new one they ask you to solve. By say equal to 2. If I say equal to 3, it will not be same. Because if I move 3 here, it will be 3 minus 3 is 0. So, which will not be same as here. If I say equal to 1, it will not be same. Because if you bring the 1 to the left, 3 minus 1 will be 2. Which will not be same as this one they asked me to solve. We must equate it to a number such that if we bring the number to the left, it will be exact the same one they asked us to solve. It will be the exact same one that they asked us to solve. So that's what you do, a small play you play. The original one, equate it to something that will be exactly as this if you interpolate. Okay? So once you do that, it means the original graph, which you have plotted, which I did just now, you go to where 2 is, draw a straight line. Draw a straight line. Where the line touch the curve, take it down. You know, I did it just now already. Where the line touch the curve, draw it down. Then you can get the values. And you write out the values of the solution of the graph, which is 0.3 and 3.7. Approximately. We just say approximately. Okay? X equal to 0.3. If you trace where this curve, where this line, because you say y equal to 2 now. We say the equation equals to 2. Remember, we say equal to 2. So what that means means you go to the line of 2 on the y-axis, draw a straight line there. The line will touch the curve in 2 spots, at 2 spots. This place and this place. Trace it down, trace this one down, and also trace this one down. When you trace them down, then you read out their values. This will be the roots of the solution that they've just asked you to solve. So pause this one and solve the equation. So pause this one. It says using the graph that you drew in the graph we just drew, use it to solve this one. So you have to find the difference between the two. Okay? Sometimes we get a straight line. The difference between the two could be a straight line graph. And then we have to plot the straight line graph. Where the straight line graph touch a linear function touch the 2 places, we take it down. Okay, for example, the one we did just now and this one, what's the difference? We have to find the difference between the original one, x squared minus 4x. Okay, it's even here. Okay, it's even here. Since it's here, let's use this one. This x squared, we say minus x now. Minus x, which is this one. Minus x. We are going to use the original graph to solve all this one. Minus x, minus 4, minus 4, minus 4 equal to 0. Equal to 0. Now we find the difference between them. S squared minus s squared will get 0 if we subtract. If you subtract this minus this, you get 0. Minus 4x minus x, you get what? You get minus 3x, right? Because it's going to be plus. Minus 4x minus s, you get negative 3x. You get negative 3x. Okay, you get negative 3x, right? Then 3 minus 4, it becomes plus 7, right? Because there will be 2 minus. 3 because we are subtracting, there's one big minus here. 3 minus 4, it becomes 3 plus 4, which is 7. So I say plus 7, right? So this is the difference between the original graph. This is the difference between the original graph given to you and this one they ask you to use the graph to solve. So that difference, you call it y. It's equivalent to your y. You know that difference is your y. So it's your y. So you write the original graph, you equate it to this. You equate it to this. So y, now you have y. You have y equal to minus 3x. Y equal to minus 3x plus 7. This one you can relate. This is a linear function, right? This is a linear one. Simple linear function. Plus 7. So you make a table of value for this one. You plot this linear equation. It will give you a straight line graph. Since this one is negative, it will give you a negative gradient. So you plot it. When you plot it, you may get a line like this, for example. You may get a line like this, for example. Then that line where it touches this place, trace it down. Where this one touches this place, trace it down. Then that will be the solution of this equation using the original graph. Do you understand? Okay, that will be the solution of this. That will be the solution of this graph. So what did we do? We subtracted this one from the original graph. We get minus 3x plus 7. We say y will be equal to that value. You know, just now when we subtracted, we got 2. We say y was equal to 2. We drew a line at 2 because y equal to 2. But this one, we got a linear function. The difference is a linear function. You make a table and plot the linear function. You got to plot the linear function. Because this is minus 3, you're going to get a negative gradient. Once you plot the linear function, where it touches the original quadratic curve, you trace them down. Where this one touches here, you trace it down. It will be the solution of this new one that they ask you to solve using the original graph. Okay, this will be the solution of this one. The same you do with this one. Find the difference between this one and the original graph. And then if it gives you a linear function, make a table of value for the linear function. Plot the linear function, it will give you a straight line. Where the straight line touches the curve, if it's a positive gradient, the line will go like this. The line will go like this. You plot it. You don't just draw or sketch. You plot the line. And then where the line touches the curve, you trace it down, you get the solution of the equation that they've given you to solve with the original graph. You get the equation, you get the solution of the thing that they've asked you to do. Now let's go to the next one. The completed square form and the graph of quadratic equation. How do you put a quadratic function in a completed square form? I think in chapter 13 we've dealt with completed square form, but as just a small reminder, completed square form are of this form. It's a little slightly different from completing the square. It's the same thing. Completed square form leads you to completing the square form. Okay, so we're going to look at just an overview. If you're given y equals to x squared plus 6x minus 4, how do we put it in completed square form? How do we put it in this format? How do we put it in this completed square form? Now, to do that, you remember the basic rule. We say half the coefficient of x. Okay, I'm going to write this one out. Like I'm going to draw 2 boxes. Okay, we're going to draw like 2 boxes. You don't necessarily have to draw box. I'm just telling you how we split them and what we do. Okay, you don't necessarily have to draw box. You write this one with x, these two that have x. You say x squared plus 6x here plus 6x in this box. Here you write negative 4 here. The constant, you separate the constant. How to put something complete. I'm just giving you an overview so you remember if you forgot it. So completed square is this format. Put something in completed square form. Okay, now what we do is to have the coefficient of x. Half it, square it, add and subtract. half it, square it, add and subtract, okay? And you can say add it to both sides, assuming there was equal to here, if they were two opposite sides. But since they are both, it's just a quadratic expression, we just say add and subtract. So half the coefficient of it, if I have 6, it means 6, half means 6 divided by 2. 6 divided by 2, I'll get 3. I'll get 3. So I get 3. Now I square 3, I add and subtract. Square 3 and do add and subtract. Square 3. So meaning I'm going to add here plus 3 square. Plus 3 square. Here, 3 square is what? 9. So I can just simply evaluate. Because here is for constant numbers. I just put 9. 3 square is what? 9. You can also write 3 square. Doesn't matter because eventually you still evaluate. Now, you factorize here, this left side. How to factorize? You write, here is square, this 3 square, this x square. Now, the simple trick, just write whatever, write the x, only x, not the square. Write only the x. Whatever sign is here, if here is plus, you write plus. If it's minus, you write minus. Say plus, in this case it's plus here, whatever sign here, not the sign here. So you write plus. Then you come to this number. Whatever number here, you know it's 3 square. Write the 3. Write the 3. Right? Then you square both. You what? You square both. Now if you expand this is a short way of factorizing the whole of this. A short method use that we can use to factorize perfect square. Because this is a perfect square. Okay, 9. S squared plus 6s plus 9 is a perfect square. So the short form of factorizing perfect square is what I just introduced you to. Now, there you go to this one. Minus 4 plus 9 is what? Plus 5, right? Okay, this is minus. Remember, this is minus 9. This is minus 9, sorry. We say add and subtract. We are subtracting it here. We are not adding it. Remember, we say add and subtract. So here is minus 9. We only add it here. We subtract it here. It's like you put it in one side, you take it out on the other side. So which means it's nullify itself. So minus 4 minus 9, you get negative 13. You get what? Negative 13. So this is called completed square form. This one is called completed square form. Now, if they want you to do completely the square, meaning you equate to 0, you continue, meaning you want to find the root. Then once you reach here, it's called completed square form. You stop. If they say put it in the completed square form of this nature, you stop when you reach here. But when they want the completed square form is to reach here and stop. Completed the square is to continue to find the values, the two values of x. In that case, you move negative 30 to the right. In that case, you move negative 30 to the right. You have x plus 3 squared equal to 30. You move 30 to the right, right? Then you take the square root of both sides. You know how to do this type of things, right? All right. Become a normal equation. Equal to 13, 1, 3. Then you take the square root of both sides. We take the square root of both sides, and then we have x plus 3 equals to root plus minus root 13. And then you move 3 to this way, it becomes minus 3 plus minus root 13. Take the square root of 13, and then to get one value, you say minus 3 plus whatever you get for the square root of this, or minus 3 minus whatever you get for this, which is 3.6. Okay, you get the two values of x. Okay, but however, let's go to the business of the day. I just did revise completed square form, how to do the completed square form and completed square with you again, chapter 13. Okay, so now let's go to the graphical part. I say plot the graph of this function. So you can see this is already put in the completed square form, not in the original form. Okay, they give you the values of x. So you just make a table for from 0 to 6. X is 0, put 0 here. 0 minus 4 is what? Negative 4. Negative 4 square is what? Negative 4 square is 16. 16 plus 2, you get 18. That's how we got 80 here. Okay? It's the same thing. Just put the value of x. 1. 1 minus 4, you get negative 3. Negative 3 square, you get positive 9. Positive 9 plus 2, you get 11. That's how you get this one. Same here. 2 minus 4, you get negative 2. Negative 2 squared, you get 4. 4 plus 4, 4 plus 2, you get 6. That's how we got it. And that's how we apply all the other values. Now you plot. You trace. I've told you how to plot. We don't need to waste time with that, right? So trace 0 on x-axis to 18 on y-axis. You trace 0 on x-axis to 18 on y-axis. Trace 1 to 11. Trace 1. You choose your scale, okay? At least you should know by now, you should know how to choose a scale for a graph. Trace 1 to 11. 1 to 11, you put a point there where coordinate 1 and coordinate 11 meets, okay? Point 1 and point 11 for this x and y axis meet, you put a point there. Now trace 2 to 6, 2 on x-axis to 6 on y-axis. This is the point where they meet. You put a point there. 3 to 3, trace it here, you put a point there. 4 on x-axis to 2 on y-axis, put a point there. 5 on x-axis to 3 on y-axis, put a point there. 6 on x-axis to 6 on y-axis, put a point there. Then you carefully join the points. All your points you carefully join there is a curve, it's a quadratic. You join, this is your quadratic graph, okay? Now, having gotten your graph, why is this positive quadratic? It looks like U. Why is it? Because here is a positive number. If here was negative, it would have looked like N, okay? The parabola would have been looking like N. So it's going to look like U because it's a positive quadratic graph. Okay, now let's move on. If any question, we'll be able to answer. Whatever question they say, find the value of this when this is this. All those questions we should be able to answer. Now let's move on. You pause the video, solve all of these, use completed square form to plot the graph, quadratic graph, and move on and be able to answer any other question that is there. Now we go to reciprocal graph. Reciprocal is like sum 2 over x. Okay, like 1 over x, 2 over x. Okay, those type of graph. Okay, reciprocal graph, they look, they behave like a twin, opposite twin. Okay, now it's a draw a graph of y equals to 2 over x from, they give you the domain, from x is less than or equal to 4 and greater than or equal to negative 4, meaning start from negative 4 to positive 4. So for your x value in your table. So after you draw that, you put the value of each one here. 2 divided by negative 4, you get negative 0.5. Next one, 3 divided by negative 4, you get negative 0.7. 2 divided by negative 1. Negative 2, and 2 divided by negative 1, you get negative 2. Sorry. 2 divided by negative 2, you get negative 1. 2 divided by negative 1, you get negative 2. 2 divided by 0, you get infinity. So people will say 0 anyway, but it's meaning does not exist. 2 divided by 1, you get 2. 2 divided by 2, you get 1. I'm saying this 2 is a constant number. Divide by whatever value the column you are doing. Here, you say this 2 divided by 3, you get 0.7. 2 divided by 4, you get 0.5. Okay, now you go to plot. Why we have two graphs that are not touchy is because of this infinity. Because of this place. Because of this place. Okay, it's not 0. It's not 0, 0. So it's not that you don't go and plot the graph here. What it means, this one will form the first half of the graph. This one will form the first half of the graph. First parabola. And why this one will form the second parabola of the graph for reciprocal graph. Is that okay? For reciprocal graph. So that's why we have this. Now you trace negative 4 on x to negative 0.5 on y. Negative 4 to negative 0.5 on y here. You trace it down here. Then negative 3 to negative 0.7 here. Negative 2 to negative 1 here. Put the point there. Right? Negative 1 to negative 2 here. Negative 0.5, you can even do for negative 0.5. Negative 0.5, even though the value is not here, you can add that value. Negative, because this one is too short. So if you want it to go down. So we do for negative 0.5, we get negative 4. If you do negative 0.5, you get negative 4 for y. Okay, so you join this one, this first part of this reciprocal graph. The second half is this way. Okay? Okay? The second half is this way. So 1 on x-axis to 2 on y-axis. Trace 1 on x-axis to 2 on y-axis. You put a point there. Okay, you can do 0.5. 0.5 on x-axis, trace it to 4 on y-axis. Trace it to 4 on y-axis to be here. 0.5. Okay. Trace 2 on x-axis to 1 on y-axis. Trace 2 to 1 is here. Trace 3 to 0.7 is here, just a little bit below 1. Trace 4 to 0.5. Trace 4 to 0.5, somewhere here. And then you join this point as a curve. So this is a reciprocal graph. This is called this is the reciprocal function, and give you a hyperbola. This is called hyperbola. Okay, the quadratic one was parabola. These ones are called hyperbola. Okay, these ones are called the hyperbolas. Okay, because they don't touch. They are half-half hyperbola. The other one is parabola. Okay, now you plot all this one. The same thing is very easy. Just buy a graph sheet, plot, do plotting, master all these things. They're very easy. Okay, now we go to types of graph. Now it's just to explain different types of graph. Okay, we have linear graph, right? We have all the linear graph. This is a linear graph where y is equal to 1. When you draw a straight line, horizontal line like this on y-axis, it means y equals to that value. Okay, it means y equals to that value. Okay, this is a linear graph, a normal linear graph of y equals to x. A normal linear graph of y equals to x. So when you plot it, you get this type of graph. Now let's take a look at this. This is called the quadratic graph, which is a parabola. This is called the quadratic graph. We've already explained quadratic graph. And now this is called what? The reciprocal graph. We already plotted reciprocal graph, right? This is called, we are just showing the different types of graph in existence that you, for your level. This is called hyperbola, okay? The reciprocal graph it gives what we call the hyperbola. While the quadratic graph gives what we call the parabola. Please take note of these words, the parabola and the hyperbolas. Okay, you need them as you go for the foundation or A-level. You need all these things, or your degree program. You need to understand what's parabola, what's hyperbola. Okay, reciprocal graph could be y equals to 1 all over x, 2 over x, 5 over x, doesn't matter. It could even be y over 1 over s squared. Could be even a quadratic reciprocal. Okay, okay, so that's that. Now we go to another type of graph. Here we go to another type of graph, which is called the cubic graph. You know the cubic graph? The cubic graph comes like this and then go up like this. This is a cubic graph, okay? This is a cubic graph. Now this is also a reciprocal graph, but quadratic reciprocal. What do we mean by quadratic reciprocal? You know, just now was just y equals to 1 all over x. The first one we did was y equals to 1 over x. But when you are having y equal to 1 all over x squared, how does the graph look? It's a quadratic reciprocal. Y equals to 1 over x squared. How does the graph look? When you plot it, the graph will look like this one, 1 all over x. 1 all over x squared. So this is a quadratic reciprocal. This quadratic reciprocal will look like this. Both of them will look like this. Two sections of the hyperbola will look like this. You know the one we did just now? For ordinary reciprocal, one goes this way, one goes this way, one goes this other side. The positive side of both x-axis and y-axis. The other one was on the negative side of both x-axis and y-axis. But this one, both of them would be, one would be on the negative x-axis but positive on the y. The other one would be on both positive x and y-axis for the quadratic reciprocal. So quadratic reciprocal graph looks like this: 1 all over x squared, 2 over x squared, 5 over x squared. All of them looks like this. Is that okay? Now we move on, still on the graph. We move to a graph of root x. Root x means x raised to power half. Please take note. In indices, when you say square root of x, they ask you y equals to root x, plot the graph. The graph will look like this one. The graph will look like this one, and we call it a parabola. This is a parabola, okay? Okay, and root x means x raised to power half. I hope you still remember in indices. Root x means x to the power of half. X to the power of half. So when you choose the values of s, you can get your table, choose values of s, and then s raised to power half, not square, okay, raised to power half. Okay, when you get your table, you put the values of x and you get the corresponding value of y, and then you plot the graph. The graph looks like this, and it produces a parabola. Okay, now we go to the reciprocal of square root of x. The reciprocal of square root of x, look at square root of x just now. Look at the square root of x, starting from here, and curving like this as if it's a quadratic graph, right? It's going to go as if it's going to go down the other side. Now, if it's a reciprocal, 1 over the square root of x, the graph will look like this. One-sided parabola, okay? The graph will look like this. The graph will look like this, okay? So you can plot all of this. You see your graph will look. Just take the value, choose values for domain, and get your tables of values, okay? Look at work examples. Choose your domains. Choose that's the values of x, okay? And plot the graph. Plot this 1 over root x. If you plot 1 over root x, you will get this graph. You get a graph like this. Is that okay? Now let's go to example. Let's take a look at more question quadratic, like what can come out in the exam. But I will be fast because we've done all of this. You say, draw a graph of y equals to 2x squared for x is less than or equal to 3 and greater than or equal to negative 3. So you draw a table from negative 3 to 3. You substitute the values of x here. You get these values of y. And then you trace negative 3 to 18. Go here, trace negative 3 to 18. Trace negative 2 to 8. Trace negative 1 to 2, and trace 0 to 0, right? Trace 0 to 0, trace 1 to 2, and trace 2 to 8, and trace 3 to 18. And then you join your curve together, you produce your quadratic graph. If they ask you to plot this in the exam. Is that okay? And then you can pause the video and do all of this one. Now let's go to exponential graph. This exponential function is in sequence in mathematics, exponential functions. You're going to do in almost everything. It's in indices. Exponential is everywhere. So you need to understand how the graph looks like when exponent is in this thing you call, apart from geometric sequences, in sequences, also in this compound interest. Exponential function is there in compound interest in mathematics. So you need to know how the graph looks like when they be plotted. Now, NET exponent is when you say y equals to 2 raised to power x, not x raised to power something. 2 or 3 or any number raised to the power of x. 2 to the power of x. You can see the difference. Before we'll be dealing with x raised to power something. Now for exponent is 2 raised to power x. You remember in compound interest is the principal into 1 plus the rate raised to power n. That n is the exponent. So any exponent is raised to power whatever quantum or quantity you're dealing with. So this graph, when you plot it, is easy. You can make a table. You say choose values minus 3 to 3. Okay, you say 2 to the power of negative 3. You can put in your calculator to give you this value. But I don't need a calculator to do this. Because if you say 2 to the power of negative 3, what does it mean? What does it mean? Let me tell you that you don't need a calculator. What does it mean? It means in indices, 2 raised to power negative, it means 1 all over 2 to the power of 3. It means 1 all over 2 to the power of 3. Right? It means 1 all over 2 to the power of 3. 2 to the power of 3 is 8. 2 to the power of 3 is 8. It means 1 divided by 8. So it means you are looking for 1 over 8. And 1 all over 8 is what? 0.125. 1 over 8 is 0.125. If you're very good with numbers, 0.125. If you do for this one, you get 1 over 4, which is 0.25. If you do for this one, 2 raised to power minus 1, you get 1 over 2, which is 0.5. If you do for this, 2 raised to power 0, anything raised to power 0 is 1 in indices. You get 1 here. 2 raised to power 1 is 2. 2 raised to power 2 is 4. 2 raised to power 3 is 8. So you trace negative 3 to 0.125. You trace negative 2 to 0.25. Trace negative 1 to 0.5. You trace 0 to 1. You trace 1 to 2. You trace 2 to 4. And you trace 3 to 8. And then you join your exponential. this exponent. Anything exponent is like this, increasingly like this, going up. Okay, a curve that is going up. This is what we call exponential graph. So this is what we call exponential graph. A curve that is going up like this is called exponential graph. And the equation is like y equal to 2 raised to power x, or y equal to 3 raised to power x, or y equal to 5 raised to power x. It doesn't matter whatever this number is. Okay, this prime number is. Okay, now we move on to the gradient of curve. How do you calculate gradient for curve? Normally, you know how to calculate the straight line gradient, right? You choose 2 points in a graph. You choose 2 points. You read their y values. The top point, you read the y value, which is 4, minus the bottom point, the y value. So it becomes 4 minus 2, like y2 minus y1. 4 minus 2, right? We say 4 minus 2 over, trace this one down, this point down, is 4 also on the x-axis. Trace this one down is 0 on the x-axis. Over 4 minus 0. So here you get 2 minus 4 minus 2, you get 2. 4 minus 2, you get 2. Over 4 minus 0, you get 4. 2 over 4 is 1 over 2, which is 0.5. It's 1 over 2, which is 0. So this is very normal for gradient of a normal straight line. But what if we have a quadratic graph? How do you calculate gradient? You choose any point. If I want the positive side gradient, I can choose the point here. I draw a tangential line. You choose a point here. Here we chose a point here. Choose a point here. You bring a ruler. You draw a tangential line. You know the meaning of tangential line? A line that touches the graph at the point you have chosen only. To touch the graph at that point only. You draw a tangential line. Then you calculate the gradient of the tangent. So if you want to calculate this gradient now, let's say we want to use the top point here, which is 14 for the y-axis, and x-axis is 4 here. If you trace it down, you can use this as a triangle. Okay, you can draw the triangle, or you can draw it up to this place. It's up to you. You can draw it up to this place and calculate the gradient. Okay, we can use this triangle to calculate the gradient. Meaning we chose this point and this point. Or you can choose this place. Okay, let's even choose this place where the tangent touches. Okay, and this one. So this is a triangle here, here, and here. So to find the gradient, you say 14 minus what? Minus 2. 14 minus 2, I'll just write the answer. 14 minus 2, I get 12. So I write 12 on top. They change in y-axis. Over change in x-axis. That's how to calculate gradient. Trace this one down, 4, and trace this one down, 1. 4 minus 1 is 3. 4 minus 1 is 3. So 12 divided by 3, I'm going to get 4. So the gradient of this curve, after we've chosen this line, gives us 4. The gradient gives us 4. Okay, so when you have quadratic, you just choose a point and draw a tangential line to touch the point. Okay, any value you choose, you're going to get the same answer. See, for this, we chose 10 and what? And 0. And negative 2, sorry, and negative 2 on the y-axis. So 10 minus 2 will be 12 over 3 minus 0, which is 3. So 12 divided by 3, you get 4. So any one you chose, you will get the same answer, 4. Okay, so the gradient is 4. So you pause this and solve the following. Now let's go to solving equation by graphical method. Okay, if you have equation, how do you solve equation? You just plot the graph. They gave you this equation, y equals to 3x squared minus 2 plus this. And then you give you the range of values of x. You put the values, you find the corresponding values of y. Then you plot your graph. Okay, now this is your original equation. Okay, they say equal to 0. When they say equal to 0, meaning draw a line at the 0 axis and trace it down. What value do you get for what's the solution? When you draw a straight line at 0, where is 0 on the x-axis? This place, right? This place. So where does it touch here? It's not up to 1. It's like negative 0.7, right? And then you trace this one to this place. This other one is 1. So we get the two values of x, negative 0.7 and s equal to 1. Finish. Once we plot graph, we can easily use it to find the root of the equation. Okay? Once we get graph, we can easily use it to find the root of the equation. Okay, now that's the first question. Second question says, first question says we should plot the graph. Second question says we should use this to solve this equation. We've done that. The third one says use the graph to solve the equation 3x squared minus 7. 3x squared minus 7. Now what we're going to do, we're going to find the difference between the first equation, the original equation, and this new equation. So, right, we're going to find the difference. So when we find the difference, what do we get? We say, let's write the original one, 3x squared, 3x squared, 3x squared, or 3x squared minus x, right? Minus x minus 2, right? This is the original equation, right? Minus 2. Three x squared minus x minus 2, right? The next one is 3x squared. 3x squared. The second one is 3x squared minus 7. Minus 7. Right? So when you subtract, you say subtract. There is a big minus here. You subtract. Between the new one they ask you to solve, use the graph to solve. If you subtract this and this, you get 0, right? Then x minus nothing, that's negative x, right? We're going to get negative x. We get negative x. Minus s minus 0 is negative x. So we have negative x. Then minus 2 minus, you know there's a minus here. Minus 2 minus minus 7. That's minus 2 plus 7. Minus 2 plus 7 will be what? Plus 5. Plus 5. Minus 2 plus 7 is a positive 5. Now you get a linear equation. You get y equal to this one. This linear equation, which is the difference between the two equations, you say is equal to your y value. Is equal to your y value. Why is it your y value? That difference is what makes this one to be equal to this one. That difference is what, if you add that difference to this one, you get this one back. So you get it one. So meaning you equate this one to the difference. You say this one equal to that difference minus x. After you subtract, you say this one, because this is the graph you have. This graph you've plotted, the original graph. Okay, minus x plus 5. Now what you do is that you make a table and plot this linear function. It's a negative gradient, so the line is going to slope like this. The line is good. You plot it, you make a table, choose the value. You can choose the same value from minus 3 to positive 3. And make a table and solve this one. And then plot this value. Once you plot it, you plot the graph. When you plot the graph, when you plot the linear graph, then where it touches the curve, you trace it down. Where it touches the curve, trace it down. Where it touches the curve on the other side, you trace it down. This will be the solution of this one. It will be the solution of this one. Because say we should use the graph to solve this equation. We use the graph to solve this equation. What I said, you say the original equation minus this equation. The difference is minus x plus 5. Then make a table of values for this minus x plus 5. You call it y equal to this value. And then plot this negative gradient. Once you get it, where the line touches this quadratic, where this straight line meets the quadratic, you trace them down, you get, will be the solution of x, will be the solution. And if you trace them down, you get minus 1.5, you get minus 1.5, x equals to approximately negative 1.5, and x is approximately equal to positive 1.5. This will be the solutions for that. Okay, so that's for that question. This is a second question. It's a plot a graph of the reciprocal graph. This is a reciprocal graph, and they give you range of value. We already learned how to do this. Okay, once you have this, you remember this is infinity for reciprocal. So this is first half of the graph, and this first. So they've given you the graph, they've given you the table, they want you to answer questions. Okay, so just pay attention and answer the questions. Is that okay? Now let's move on to, let's summarize quickly to pause the video and solve all of this what we have talked about. We don't have to say sketch this one. It's just a sketch. You can choose few values and then you sketch a straight line graph. This will give you a straight line. You can say, if for sketch, you say when y is 0, what will be the value of x? And when x is 0, what will be the value of y? And then you sketch. You just sketch, okay? Sketchy is just easy. You just sketch. Sketchy is just to find the value of x and the value of y, and then you join. Okay? Sketchy quadratic function. That's what we do. So for sketch, you just find few values. You don't have to find so many values because it's different from plot. Plot is like you have to include every value possible in order for you to get. For sketch, the graph intersects y at s equal to 0. When s is 0, find the value of y. Okay, you get y equal to 15 when x is 0. And then when y is 0, find the value of x. You get two values of s, the quadratic. You get two values of s when y is 0. Okay, now once you get that, you'll be able to sketch your graph. You'll be able to sketch your graph. Okay, now what are the points we talked about? When x is 3 and 5, I think we got 3 and 5 for the values of x, right? 5 and 3. And y is 0 at that point. So I'll put my point here. X is 5. I take it to y is 0. X is 3, take it to y is 0. X is 5, take it to y is 0. Right? I already know my curve is going to be here. And when x is 0, y is 50. I take it here. So I draw a curve round here. Because it's just a sketch, you don't have to do so many points. And then you bring it up this way. That's how we do sketch. If you want to do sketch, you say when y is 0, find the two values of x if it's a quadratic. And when x is 0, find the value of y. And then you just sketch. Sketch the quadratic. Is that okay? So for sketching, it's not plotting. You just sketching. You find the value of x when y is 0, find the value of y when x is 0. And then you sketch. Is that okay? So these are different sketching of cubic function. This is a cubic function. This is when you sketch based on what is given to you, and then this is what you get for your cubic function when you sketch. Okay, different sketching for cubic function. Okay, for this one, they say sketch this one. This one is addition. If they say sketch this one, you can see x minus 2, x minus 3, x minus 5. Meaning if you equate each one to 0, if y is 0, you equate this one to 0, x will be equal to what? 2. X equal to 3, x equal to 5. So when y is 0, x equals to 2, we put a point there. For sketching is very easy. When y is 0, s is 2, x is 3, and x is 5. Then when x is 0, what is y? You must find that one also. When x is 0, when you put 0 for s, what will be the value of y? You have to calculate. What will be the value of y? Okay? What will be the value of y when x is 0? We get negative 30. X is 0, you put 0 here, 0 minus 2 into 0 minus 3 to 0 minus 5. So you get minus 2 times minus 3, that's positive 6, times minus 5, you get negative 30. So you trace s is 0, you trace it to y is negative 30. You trace it here, okay, you put a point there. So from here, you draw a sketch that will pass through here. Because you know it's a cubic function, we pass through here and then pass through 5 and go up. It's just a sketch, you sketch. This one you are not plotting. So sketching is the easiest. It's even easier than plotting a graph. For sketching, you choose when x is 0, what is the value of y? And when y is 0, what are the values of x? Okay, once you get those values of x, if it's quadratic, you're going to get two values of x if y is 0. If it's cubic, you're going to get 3 values of x, like this case when we got 3 values of x. And then you just sketch. Is that okay? So this is how we do. This one is in additional maths. Okay, this is additional maths. But if you are good in additional maths, this one will be super easy for you to sketch a cubic function, quadratic function, and any function they want reciprocal than plotting the graph. Is that okay? Okay, pause the video and sketch all of this. Sketching reciprocal is the same thing we just explained. When x is 0, what do you get for y? When y is 0, what do you get for x? Then you sketch. Is that okay? So this is a quadratic reciprocal. When you sketch them, this is what they look like. Okay? So here is an example. It says sketch the same axis, the graph of y equals to 1 over s, y equals to 3 over x, labeling each. Same axis. You have to graph these two graphs. You sketch them. Okay, when you sketch, you say when x is 0, what you get for y. When y is 0, what you get for x. Then you do for both graphs, you sketch them, you get this. Okay, now exponential function, also we sketch. When x is 0, what we get for y. When y is 0, what we get for x. Whatever we get, we sketch the values. Okay? Okay, so I think with this, we are gradually coming to the end of the entire chapter. So we thank you for joining us, and then we hope to see you in chapter 19 of this Maths IGCSE. Thank you.